Hello friends, welcome to another video on logical reasoning from Edupedia World. In today's session, we will be covering a concept called direction sense. Now, in this particular concept, you will be seeing questions based on the compass. So, you will be making use of directions, the general directions, that is north, south, west and east, and the four sub directions. So between north and east we have the northeast direction, between south and east we have the southeast direction, between south and west we have the southwest direction, and between west and north we have the northwest direction. So we will be making use of these four primary directions and the four sub directions, so all in all 8, and the relative positions of left and right. These are the concepts we need to solve questions on direction sense. Now, what do I mean by the relative position of left and right? Okay, so when you are headed in the general direction of north, your left is towards the west and your right is towards the east. On the other hand, if you are facing the south direction, your left and right gets reversed. Now your left is towards the east direction and your right is towards the west direction. So we see that by changing the direction in which we are facing by 180 degrees, we have changed left and right. Similarly, when we are walking towards the east, left is towards the top and right is towards the bottom. And when we are walking towards the west, left is towards the bottom and right is towards the top. So we need to keep in mind the 8 general directions of north, northeast, east, southeast, south, southwest, west, northwest, and we need to keep in mind the relative position of left and right. This will enable us to solve these questions with absolute ease. Now let us apply these concepts. Okay, let's take a look at various types of questions. So, for example, I have a question with me which says, if I move 5 kilometers to the east and then 12 kilometers north, how far away am I from the starting point? So to solve this question, first of all I will move 5 kilometers to the east. Okay, so I will draw my lines. Okay, I start at a point where the cursor is pointing right now, and I move 5 kilometers towards the east. After walking for 5 kilometers, I move 12 kilometers to the north. Okay, so I have a line extending for 5 kilometers towards the east, and then a line extending for 12 kilometers to the north, and I have to find out how far away am I from my starting point. Basically I have to find out this diagonal straight line, okay, this distance. Now, as you can see, we have a triangle. Okay, this figure makes a triangle and it is a right angled triangle. When I say a right angled triangle, I mean that two lines will form a 90-degree angle. Okay, so when I move from my starting point to the east and then I take a 90-degree turn and move north, I am forming a 90-degree angle over here. Okay, I have gone perpendicular to the first line. So we can apply Pythagorean theorem here. What is the Pythagorean theorem? Let's quickly take a look at that. Pythagoras stated that if you have a right angle triangle, okay, so the red triangle in the center is a right angle. So Pythagoras stated that if you form a square taking the perpendicular as one side, and if you form another square taking the base as another side, then the sum of these two squares will be equal to the square formed by the third side, the diagonal, which is commonly known as the hypotenuse. So we come up with an equation Suppose the perpendicular side, the distance of that is A, and the measure of the base is B, and the hypotenuse is C. So we can say that the square of A plus the square of B will equal the square of C, or the square of the perpendicular added to the square of the base will give me the square of the hypotenuse. So I get A squared plus B squared is equal to C squared. So in this example I get 16 plus 9 equals 25. So I know that C squared is 25. So in order to find out the value of C, I will simply take the square root and I will get 5 as the answer. Now we have to apply the same concept to our problem. So in this case, your perpendicular is 12. So the square of the perpendicular will be the square of 12. That will give you 144. And the square of the base will be the square of 5, which will give you 25. Now once we add 144 and 25, if you do the calculation quickly, you will get 169. So 169 is the square of this diagonal. So to find out the length of this diagonal, I have to take the square root of 169, which gives me 13. And that's my answer. If I move 5 kilometers to the east and then I move 12 kilometers north, I am 13 kilometers away from the starting point. Okay, and this solves my problem. So I hope Pythagorean theorem is clear to you. Of course, you can go back and you can go over Pythagorean theorem once more. Along with the general directions and the relative position of left and right, we will be using Pythagorean theorem in some of the questions, and this will enable us to solve all the problems pertaining to direction sense. Okay, let's move on to the next question. So example 2. Okay, it's very similar to the first example. The question says, if I move 8 kilometers to the east and then 16 kilometers north, which direction am I in from the starting point? So again we'll draw a diagram. I move 8 kilometers to the east and then I move 16 kilometers north, and now I am at this vertex. From the starting point, in which direction am I? So from the starting point, which is here, if you use a compass, you will see that you are in the northeast direction. So it's as simple as that. Okay, we saw that we are in the northeast direction. So these are the basics of direction sense. Let's move on to questions that will use these concepts in a slightly more advanced manner. So in this example, the question says a person starts from position A. Okay, so I start from position A. This the blue line starting from the extreme right is the position A. Now the best way to solve these questions is to simply draw lines. Okay, take a piece of paper and keep drawing lines as the instructions are given in the question. You will come up with an accurate graphical representation, and using that we can easily answer the question. So a person starts from position A, that is right here. He goes towards the west. So the person moves west following the cursor and then takes a left turn. Now when a person is moving towards the west, okay, imagine you're moving towards the west, you will realize that left is towards the bottom. So I drag the line towards the bottom, I take it down, I've taken a left turn. After moving for some distance, again the person takes a right turn. Now when I'm moving in the south direction, my right is towards the west. Okay, left and right get reversed. That's why it's very important to know the relative positions of left and right with respect to the direction. So I take a right turn and I keep moving. Okay, and then again he moves 45 degrees left. So after moving for a while, he moves to the left. Okay, but he doesn't take a complete turn. He takes only half a turn. Okay, he moves 45 degrees to the left, and I'm moving in this direction. Now the question is, in which direction is he from the starting point? So it becomes easy for me to answer from the starting point. So this was my starting point to the extreme right, and now I am here. So from the starting point, now I am in the southwest direction. From the starting point, if you come here to the extreme right and you put a compass here, you will see that the point of the destination is in the southwest, and that will be your answer. So these kind of questions come in direction sense. Okay, let's take a look at one more example. In this particular question, example 4, the question says a person X is standing at a point. Okay, so we have plotted X here on top. Another person Y is standing to the south of X, facing X. So we use a blue line and we go in the downward direction, that is the southward direction, and we position Y to the south of X, and Y is facing X. When I say Y is facing X, it is implied that X is also facing Y. Okay, they are facing each other. So Y is facing in the northward direction and X is facing the south direction. Now this question asks us to apply our knowledge of the relative positions of left and right. So we come to know that Y's friend Z is to the left of Y. Alright. Now Y is facing north. So Y's left is towards the west and his right is towards the east, and Z is standing to the left of Y. And X's friend W is standing to the left of X. Now X is facing the southward direction. So X's left is towards the east and X's right is towards the west. So his friend W is standing to the left of X. So we position W to the left of X. The question asks, in which direction is Z standing with respect to W? So with respect to W, in which direction is Z standing? So if you look at it from W's perspective, from where W is, Z is in the southwest direction. We see that Z is in the southwest direction. And as a continuation of this, the next question is, in the previous question, what is the direction of W with respect to Z? So now when we look at it from Z's perspective, from where Z is standing, W is standing in the northeast direction. Okay, you can place a compass where Z's position is, and if you look at W, then W will be where the compass is pointing towards the northeast. So we see that the direction changes with relative positions. From where W is standing, Z is in the southwest direction, but from where Z is standing, W is in the northeast direction. Okay, so these are the concepts and a few basic questions on direction sense. We will have one more continuation part, that is part 2 of this video, where we will take a look at a few examples that make use of all of these concepts. Okay? And after that, your understanding of direction sense will be pretty clear. So do join me in part 2, and I'll see you in that video. Thank you.